In our next example, doing this exercise, let's try to declare an array. Array named A. This is an array. Array size has 3 elements, and this is an array of integers. And we also provide an initializer 0. And this initializer includes only value for the first element, but the rule is that when an array of objects is created, and if it's short of all of the values included in the number of elements right here, then 0 is used to initialize every element. So basically doing something like this or something like this or something like this would be exactly the same. I prefer to use this style to indicate that basically every element of this brand new array should be initialized to 0. So we can just use three next available locations in our memory to give it to our array. So it's assumed that this would be the first element of an array. The next memory location will be given to the next memory, to the next element of our array, and this is the third one. We can just say that this is array element A0, and likewise this is array element A1. This is array element A2. So we have 3 elements that we are allocating, and each single one of them is initialized to 0. So we initially indicate that the values of these 3 new integers that we're trying to use in our memory are set to 0. If we try using the name of this array alone, just by itself, this would be an expression. And the name of the array is an identifier that has a value that remembers the address of the first element in computer memory. In our case, the first element of our array A0 happened to end up in location AC, hexadecimal AC. So the numeric value would be AC, and the data type typically you would indicate that this is just an array type, int array, because A is name of array, its data type is integer array of integers. But the numeric value of the name of the array is the address of the first element of this array in computer memory. Similar to what we tried before, x equals a. X is an integer, a is an array of integers. This is an integer, this is an address of an integer, so this again would be something illegal. Number 16. If we use a notation for an element array, of course, using subscript operator will dereference this address that array name represents, and altogether will give us access to the values stored in this element of an array. So A2 is stored right here in this location, and we have initialized everything to 0. So of course when we do something like this, we get numeric value 0, and of course this is an array of integers, so this value is an integer, and of course this is another expression. Likewise, we could construct entire statements using array elements, and for example right here we could say a index 2 equals x. So I use a semicolon. The language construct that we're dealing here is a complete statement. And the value that's being assigned right here is the value of variable x. So this is 1. And of course the data type on both sides, this is an integer right here, and this is also an integer in computer memory. So both sides, the data type that this statement is using is an int. Number 18, let's try to combine variable x being used as an index in this array, and we'll try post increment operator. So this is a complete statement which increments array element, and of course array index is 1. X continues to be 1, so we're actually trying to use this integer in memory indicated by this array element, and the value, the numeric value, I would say that the numeric value that is being returned by this or manipulated by this statement would be a 0, because this is 0, and of course the data type is an integer, and this is also a complete statement. But we should say that this has a side effect, and so this side effect is that A1, which is a combination of index and the name of the array, this A1 returns a value of 0, but also part of the statement A1 becomes 1. So you see that there is a little bit of a interesting side effect here, is that first this value is returned by this sub-expression, and only after the value is being returned the actual element is incremented. Well, anyway, the outcome of this is that of course A1 is incremented, but its increment is done as a side effect of this statement. Number 19, let's try basically the pre-increment, or prefix increment. So instead of doing this, we can try over here something like this. In this case, we already have 1 stored in this memory location. We're still referring to A1 because x is still 1. And in this case, clearly, what we return back is that the prefix increment increments the value, so it becomes 2 if we follow the sequence of our statements. And of course the return value is 2, numeric value is 2, and of course we're changing a plain integer in computer memory, and this is also a complete statement that we're using. But there is no side effect. in this case. Why? Well, what's the difference? Here everything is done in sequence. We find the right integer in memory, we change its value by incrementing it by 1, it becomes 2, and we return this value. So I would advise you to stick with prefix increment version of ++ and as well -— whenever possible, because it has less things to worry about, whereas this has more things attached to this, and we can refer to them as side effects.